I prefer if you would title this the Pythagorean. Oh, here it is right here. Sorry about that. She did put it right. She did. The Pythagorean identities. These are big, important identities. They can be used in a lot of different ways, especially in calculus, but man, they're important. So, it's the unit circle. And remember, unit in math has two meanings. One is, what kind of measurement type did you use, inches, centimeters. But unit also means one. Unit means one. Now, the unit circle means the radius is 1, yeah? So if I look at this triangle here, if the radius is 1, and this is x and this is y, then doesn't the cosine of theta equal adjacent over hypotenuse? And so in the unit circle, x is just cosine. And by the similar thinking, y is just sine. Because if the hypotenuse is 1, then that part of the fraction is just pretty much ignored. And x is cosine, y is sine. Are we cool? All right. Now, if we take the equation of the circle, we know that a circle with a radius of 1 centered at the origin has this really nice clean equation, yeah? Now let's take that to trig. What did we just say x is equal to? Cosine. So cosine squared, and what do you know y is equal to? Sine. So sine squared equals 1. I gotta say, most people write this in the opposite order. I don't know why, but it's typical that you see this sine squared plus cosine squared is 1. That is the biggest identity in all identities. It is gigantic. And you can see it's actually true at any point here. Isn't the sine at 30 degrees 1/2 and the cosine at 30 degrees root 3 over 2? Well, what's that squared plus that squared? 1/4 plus 3/4 is 1. That's true everywhere. Root 2 over 2, root 2 over 2. That squared is 2/4. The other one squared is 2/4. That's the 1. They always add to 1 every time. You with me so far? Okay. That means then that if I rearrange that a little, I could also say that sine squared, an equivalent form, is equal to 1 minus cosine squared if I rearrange that. Or, if I solve for cosine squared, I could say cosine squared is 1 minus sine squared. Those are alternative forms of that same identity. So far, so good? Okay, cool. Now, let's take this baby and get a little tangenty identity. Start with sine squared plus cosine squared, theta equal 1, which is what we just said we know to be true. And would you now divide by, what can I divide by to get some tangent action here? Cosine squared. If I divide by cosine squared, then I have to divide everything by cosine squared. I can't say, hey, I'll do this one, but not that one. It has to be everything. Now, what is the result? Sine squared over cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And what's 1 over cosine squared? Secant squared. That is the second big identity. Tangent squared plus 1 is secant squared. It's just a form of this one where we throw in a dividing by cosine squared to get some tangent. You with me? So if you look down at the bottom there, or the middle row actually, what's tangent squared also equal to? Secant squared minus 1 if I subtract the 1 over. And what's cosecant, what's secant squared below that equal to? cotangent squared plus 1. That's actually the same as that one, but you get the idea. Yeah? Alrighty. Now, last one. Let's see, I need a little different color here. Let's try a little pink. Okay. Sorry, guys in the back, you're not going to be able to see this, but oh well. If you start with, no, I can't, I just can't do it.
There's some blue in the orange.
Blue?
Purple, use orange.
How about
Use
that?
orange. That's
Orange?
green.
Orange?
No.
Not that?
It's urban air color.
It's fall. It's falling.
No, it's
Wow. Some strong feelings about it. Okay, start with sine squared plus cosine squared, and this time we're gonna, where's a brown? Ooh, that's really gross. That's like
That's the best.
poop.
Ew,
Right?
my color is cute.
Go green.
It's literally vomit. Black.
Dark green. All right,
That's
cool.
also gonna be vomit.
Okay. What do we? Which of the two trig functions do we still not have an identity for? We have sine, cotangent, and cosecant. How can I get cotangent? Divide by sine or sine squared? Okay. Oh, that's nice. Isn't that fallish?
It looks nice with the orange.
Yeah. It's choices. Choices are good. So what does that become then? 1 plus cotangent squared equals? What's 1 over sine squared? Cosecant squared. Box that one. That's the third big one. Or any equivalent form. Cosecant squared is? No, this is it.
1 plus cot.
1 plus cotangent squared theta, or cotangent squared is? Cosecant squared minus 1. Would you just add in here also, what if you had cosecant squared minus cotangent squared? What's that equal to? It is 1, yeah? Sometimes you'll see that one. Very cool? All right, now you have a new family of identities to choose from to use in a prove-it problem. So, take a look at this bad boy. Okay? So, obviously here you don't have to write the original problem, it's on the paper for you. What's the first thing or one thing I could do? Top is 1. One change at a time. Okay? If you don't write anything on the right, it's just assumed that you are not changing the right side, so you're good. Although you can write the cosine squared on the right if you like. Okay? What next can you do?
Secant squared. The bottom could be
1 plus tangent squared is?
secant squared.
Secant squared. That's one of the ones we just did in the box, yeah? And secant squared in the denominator is the same as cosine squared in the numerator. And you are done. The what?
I got it.
Okay. Are we good?
Yes.
Okay. Let's try 2. The left side and the right side are both a little complicated, but let's work the left side, shall we?
Yeah.
What do you want to do?
So first we should cancel. Oh wait.
Where B, that's beta.
Isn't that beta? That's like physics. It's like a beta part.
Yeah, the whole Greek alphabet's over there. Beta is the second letter of the Greek alphabet.
Look at us.
Okay.
I do the difference between
So what do you want to do first? Eric, what do you think? Just tell me one thing we can do, and I'll tell you, no, that sucks, or it's great. Okay, cool. All right, you could do that. You could call it cosine over sine. You could get a common denominator. A lot of different choices. Now, it's not like, as long as you don't break math, you won't, keep yourself from getting there. It's just you might add a step. So yeah, go ahead. You can, okay, only if it was multiplication. Can I cancel those?
No.
No, so don't, that's the one thing you cannot do. That is just sine over cosine. So Gosh, is that really an identity though? You could find me in a book somewhere where it says 1 over cotangent cosine over cosine.
But the identity is changing cotangent, and that's just algebra at that point. And you said algebra we could do in our
So you're changing,
cotangent
To sine over
to cosine over sine, and then you just, because you just do
oh, okay, so you're saying do that in 2 steps.
No, I'm saying no.
Oh, yes, you are.
You can see that one?
No,
Algebra, you
no,
said algebra is
no,
fine.
no.
But yeah.
Okay, now, I don't mind if you flip this one and replace
In
that.
the last problem, we just did it.
What do we do?
In the last problem, we literally just said secant 1 over secant squared is cosine.
That's true. So the only identity you could say is this is tangent. That's an identity.
Looking at cotangent, 1 over cotangent, I can literally say that is sine.
Okay, so I feel like all these choices are terrible and you should instead get a common denominator. Okay, so let's instead do that. The reason is that this is all one big term. It's not a sum over there, so it seems like maybe we should get it all together over here. So what is the common denominator? 1 plus cotangent squared b over
Cos B.
cotangent c. Cotangent b. Okay? That's an identity. What's the bottom equal to?
Oh my god,
Come on, this is an identity. Look in your box. What's 1 plus
Cosecant squared
cosecant squared beta
or B.
or beta? Okay? Now we're talking.
And we're kicking with gas on this.
Now what? Now work with the
I say that.
denominator. What can you do in the denominator?
now we can change it to
Secant squared.
No, I
minus
say that.
secant.
a 1
Yeah.
a 1 over cosine over sine.
You just think I'm like this.
And then multiply by cosine.
1 over. What are you doing here?
1 over tangent.
1 over tangent or tangent in the numerator?
Yeah, that works.
Okay? Cotangent in the denominator is the same as tangent in the numerator. That's good. Okay? What else?
I have to take tangent into sine and cosine.
Sines and cosines. Oh, you're getting there. You're getting there.
I can't.
Dude, it's only been 3 steps. You're going to do 20.
Is sine
Not-
Wait, you know how
not for
small
this
those
one.
boxes are?
Well, you better write small. So now what?
sine? It's gonna be 1 over sine squared.
Okay, this is 1 over sine squared. Now, do you want to use both of those and put 1 over sine squared, or you want to split it up and do only one of them 1 over sine?
Let's just do one of them because we're trying to get one at the end.
Running out of room.
The left side.
We're
Crazy
working
how
on the
that
left side. Okay, so
Say one.
cosecant is 1 over sine for one of them, and the other one we're going to leave a
Yeah.
cosecant. You follow?
Wait,
No, I do not follow.
Yeah.
You lost me. I don't know if you Yeah.
Okay, cosecant squared is cosecant times cosecant, yeah?
Yes.
Okay, start from the beginning, really?
No.
Okay. So this step was too much. See, this is why you can't do too much at once. So what I'm saying, or somebody said, is let cosecant squared be cosecant cosecant. You follow me?
Do I have to draw that?
Okay. So now, what is one of those cosecants? One of those cosecants can be replaced by 1 over sine. The other one stays a cosecant. Sine b divides away. You're almost there. What's the cosecant in the denominator? Or sorry, what's cosine in the denominator?
secant.
Secant in the numerator. And the order being different, if your teachers had told Nazi, then they would make you switch the order in the second step. That's not good. Yes?
So for this, if you just, on the second one, if you just change cotangent straight into,
Cosine.
cosine over sine, could you just, for the next step, you have to say cosecant times sine over
Yes. I was doing what you guys wanted to do.
Move that slide straight up to the top, and that'll be like a top. Or do we have to show that step?
Yeah, I don't feel like that would be clear. No, that's not an identity. Okay, all right. Let's try another one, shall we? Okay, so 1 plus cosine is great, but I don't have an identity for 1 plus cosine. All my identities at the top of the page are for squares. So what do you reckon we should do?
We should add them like a common.
Add the two together. Now, when you get a common denominator, isn't it 1 plus cosine times 1 minus cosine?
No, it's 1 minus cosine squared.
Okay, which is 1 minus cosine squared.
But you have to do
And if you wanted to do that in one step, I would be okay. Okay? So let's say this is optional. And I just don't want to lose anybody. All right? So the first one, what did you multiply top and bottom by? 1 minus cosine. And the second one, what did you multiply top and bottom by? 1 plus cosine. All right. Now either way, I feel like you're still going to have to do 2 steps. So what do you, after 2 steps, get to? Where does the top come? 1 plus 1 is 2. The cosines drop away. Okay?
Can I do like this? If I had gone like straight from the 1 plus cosine times 1 minus cosine, we had like 1 minus cosine squared thing. Wait, never mind.
Okay, so now what? What do you think?
sine squared theta.
The bottom is sine squared theta. That's an identity. 1 minus cosine squared is equal to sine squared. Okay? Sine squared in the denominator is the same as cosecant in the numerator, and you are done. All right. Now it takes practice. So would you either on paper or a whiteboard try this one on your own? Or should I use paper to get a problem set? No, whiteboard? All right, here's the markers. There's also some markers here. Here's some markers.
Oh, boy.
I'll take my markers. If you want to use the whiteboard itself, that's fine too. You should always start by writing your problem, yes. Get over it. Just one.
Oh, it's Mark.
It's my dad's name.
Feel free to use your notes the first few days, and gradually get them memorized.
These are reverse stories. Why is there no square? It's all stiff. Oh, no.
Yeah, you know,
Sorry. Are we funny?
I would get a common denominator.
I don't know how to do that.
You don't know how to do that?
Oh, I said I don't want to.
Oh.
Oh, that's just funny.
I don't know if it helps to actually, does it help to really multiply them together, or is it better to just keep them apart?
I don't want to add.
I think it's probably better to keep them apart. Oh, you definitely want to get a common denominator. The only question is, do you want to multiply it out or not? That's kind of funky.
Does this even work?
I don't know. What's 1 plus cosine of A? Is it 1 squared plus cosine squared? Is that how you square a binomial? No, it is not. Remember, when you square, there's FOIL going on. First, outer, inner, last. It's not just 1 plus cosine squared. It's 1 plus 2 cosine A plus
Cosine.
squared. Yeah? Now we're getting there. Now we're getting there. All right, all right.
I'm not struggling.
Nope, I still don't see it. Now we're getting there. I see it. Boom. Okay, now what?
No idea.
Well, that's great.
Simplify. Things are that easy. Simplify stuff. What can you do?
Take away the sine of n.
What is sine squared plus cosine squared? The fact that they're not next to each other don't mean nothing. What's sine squared plus cosine squared? One. So if you replace those combined with the one, what is the top? 2 plus 2 cosine of A. Okay. Actually, maybe I'll do that in 2 steps. You don't have to do this in 2 steps, but so my work is clear. These two together are 1. All right, then what? Factor out of 2.
I don't want to room to this.
Right, smaller. Okay, if you factor out of 2,
You can cancel the two.
you can cancel A,
Cosine A.
1 plus cosine A, the whole sum, huh?
Oh, yay. This makes me so
And
happy.
2 over sine A is? What sign in the denominator?
2 secant.
Cosecant. And we are done. All right. Takes perseverance, it takes flailing away until you succeed. Don't stop flailing. Okay, here is your homework. Should we start with the new ones while they're finishing their marks?
Yeah, it's like identity. Dude, that's I'm like, you're just like right under my foot. I get there.
New ones.
Yeah, we'll help you with this then.
What are they, number 7 and 8 or something? Thank you. Yep. What? 7, 8, 9 are the new ones.
Turn paper sideways to write vertically.
The box is a little longer if you
Goody.
rotate it.
This just makes me so happy.
I don't even know.
Is this something we just did?
A little different.
I'm not.
I did? Oh, okay, actually, first of all, be careful here. So, some problems are skipped. Make sure you understand and look at the box number. You see how it goes 1, 3, 4, 7, 8, 9, and so on?
Yeah.
These two are right problems. It does not go in order. We're going to replace problems once in a while and give you more practice on harder problems and less practice on what I would think of as not important problems. So please read the problems carefully. Do the right problem.
Oh, yes, that was that one. Oh, you skipped two.
Yes, I skipped 2 and stuff, so please pay attention to the problem numbers.